Hey, so this is the video that you all been waiting for, the shirt video. So the shirt of this week is this one. Yeah, Stormtroopers. I was born in the 80s, guys. I love Star Wars. Star Wars is very important to me, so that's my favorite shirt. And I'll ask you in class. Okay, now let's go back to FMEA. We're looking at causes now, right? So we saw that we have to fill out the failures or the process step, the failure, the effect. Now we go to the causes. So the causes are the causes of the failure. Why the failure has occurred. So why is the temperature too high? Well, it could be because you set the temperature wrong. Why the PO got incorrected? Because it was a type error. Why we have contamination? Why did they drop the call? We didn't have many representatives, and so forth, so on, right? So in this example, baking the cake, which is one of my small set of culinary, let's say, talents, or capabilities, not a talent. So, it could be because they set the temperature wrong, it could be because of a bad thermostat, or someone was tempering my cake. So maybe you have someone in your house that's boycotting whatever you do. So you have to pay attention to that and see if someone is not changing the temperature of your oven when you're not looking at. Maybe your arch rival, evil, twin brother that live in the basement. Oh, just kidding. That's Simpson. Okay, that's another thing. So if you never seen the episode where Bart have a twin evil brother that live in the basement or in the attic actually. Okay, yeah, so watch that. I think it's a Halloween one. Anyway, so you can have different causes for that problem to happen, right? So still on the oven temperature is too high, but you have different causes. So I didn't kind of fill out this, but this will be the same thing, right? Temperature too high could be here and here, and dry cake will be here. Oven temperature will be here and here, right? So that's just the same problem, right? So the next column will be current controls. So what is the existing methods for you to find out? Oh, this is not good. A little better. To find out what's happened. It's still bad. And what are the controls to detect things or the controls to prevent things, right? Depending on the FMEA, you can do one or the other one. So what existing methods like audits or checklists or SOPs or whatever it is, right? So do I have a recipe check temperature? Do I have a spell check? Do I have a misproofing? Or when do I look at quality of the problem? How long does it take for me to look at? So let's say that I have some controls now in place. I have a check temperature before baking. I have just the experience of the thermometer. And maybe I can put some patrol. I have some patrol watch the oven, or nowadays have a camera to look at there and see if anyone is touching my oven. This is things that are happening now to prevent or detect or understand when problems are happening. Okay. So we're going to do this, and then after that, okay, we have the qualitative side. We need to transform this into quantitative. So then we're going to calculate the risk priority number. So the risk priority number is a multiplication of three things: severity, occurrence, and detection. So remember, we have the failure, which has an effect, right? And the effect could be really bad or not that bad. We have an occurrence, would be how often that happens, and we can have a detection or controls to see how good are we in preventing that or happening, or detection if that happened. So we want to change to quantitative, which was the description, to something qualitative to something quantitative. Okay, and these are the tables that we create. So we create three tables, one for severity, one for occurrence, and one for detection. And then for each failure, we can have a degree of severity, a degree of occurrence, a degree of detection. So it could be very bad if happened, but it could happen, very unlikely to happen, right? So it's not going to be a high one. but it can be very bad and it can happen all the time, and then it will be a very important one, right? So you guys have on your notes examples, and here are some of them. This is a BMW project that I did a few years ago with inventory inaccuracy. So you don't have to create the severity from 1 to 10, but 10 is the worst and 1 is like no effect. The same thing for frequency. So in this case, it was inaccuracy. So we understand that the system being higher than physical inventory was worst. Being lower is also bad, but not that bad. And it just basically a comparison between them, right? So comparing different failures with each other. So the importance is the one, it's more important than the other one. It's not on the right location, so it's not that bad. It's not that the system is wrong, it's just that it's not in the right location. And the least one would be some non-value added. It just take more time to do stuff. And then we did occurrence more than once a day until less than once a month. And we did likelihood, it will only be detected during assembly, which is really bad because they go assemble the car and say, oh, we don't have the parts. Or you can say, oh, that's 6 days before assembly. Say, oh, we have enough time to order more from the supplier, right? So this is another example. This is the example that we were going through. So you have burn or dry severity is all the same as a 10, but then the occurrence is different, right? It's very unlikely that you have a twin brother that live in the attic and also try to sabotage your cake. But maybe temperature wrong is not that bad because I don't have a digital oven. I have the ones that you have to go right or left, and maybe it's not that good. And then detection also, how can I detect that and that problem from happening, right? So you first have to create the 3 scales and then classify all the failures into those scales. And then you calculate the RPN, which is the risk priority number, by multiplying these 3. Sort them from higher to lower, and then you'll find out the most important ones. So after we have all of them, a lot of times we do a Pareto chart, which will put like the higher to lower. So we find out the higher ones that we did with that project with BMW. We found the higher ones, and then we tackle the higher ones, right? The most important ones. And then you have something like this, where you have the most important ones, and then you can kind of couple that with the implementation plan saying, okay, these are the ones that actually we need to work on, and that's how to work on. So you can do 3 different things, right? You can reduce the effect, which is kind of the most difficult part. You can reduce the likelihood, which is usually the easiest part to do, and you can, or easier than reduce the effect. And you can increase the controls, right? Making sure that you identify what happened. And also the easier part are these 2 last ones. Next steps, now you can collect data, you can test, you can improve process and do all that good stuff. And then you can recalculate the RPN, right? So that's what we usually do when we have FMEAs in capstone projects. We calculate all the FMEAs, say, oh, you have 5 things that are more than, or 10 things that are more than 500. So, if you do those things, you're going to have just, you're going to have the 5 things are going to be higher than, you're going to be lower than 300. So we reduce the RPN of these amounts, right? Or have better ones than you have before. So those actions are going to reduce the RPN, and Dave is going to do all of them, as what I see. You can reevaluate and compare them. Okay?